So the first thing that we're going to talk about this morning is your homework from yesterday, deciding between availability solutions. The idea was that you were going to sketch out and look at a couple of different scenarios to figure out what the right availability solutions were for these people and what changes you need to recommend to their people, process, and technology. I said that you could consider hardware, so if you wanted to throw CPU, storage, networking, whatever else at it. You could make changes to their SQL Server instance if you wanted to do upgrades, change SP configure settings, change things about the application. And you could change people as well. You could recommend to hire folks, implement processes, change the way that people work. And in the first scenario, we said our always-on availability group was bringing us down. This is a team of 5 developers that had a simple 2-node always-on availability group. This is the primary, let's say, and this guy's his synchronous secondary. So that every time people were doing inserts, updates, and deletes here, those inserts, updates, and deletes are getting written down to the second SQL server. Now, they did this because they had fairly ambitious server offline goals. In the event of one server going bump in the night, they want it to automatically fail over to the other SQL server, ideally with less than a minute's worth of data loss and being down for no more than 60 seconds. They don't care what happens if the data center goes offline. They're completely fine with it because they have all their app servers in the same data center as well. They want automatic corruption repair. This is kind of ambitious here, this 1 minute and 1 minute corruption protection, which did make sense for always-on availability groups, which offers automatic page repair. That was one of their deciding points. And in the event of oops deletes, they're willing to go back to backup and recover that stuff. They shot all of their money already on SQL Server Enterprise Edition, a couple of really nice boxes, fancy local solid-state storage. They didn't have a SAN. But this is doable in terms of cost. It's cheaper than a SAN typically. 120 gigs of data and growing in one database. And they're running this stuff's not the newest. I mean, it's a little bit old. They bought this stuff several years ago and implemented it. It worked okay in terms of performance, but every now and then, for some reason, the SQL Server just goes completely unresponsive. Things seem like they've locked up or failed over, and that's the extent of their troubleshooting skills. So I asked you 3 things. What changes would you recommend? What are the benefits? And what are the risks? That benefits and risks thing is really useful when I'm trying to get someone to change their behavior. When I want to get them to do something different, I have to explain what the promised land looks like. Like, all right, when you do this, you're going to get these things in reward. However, I need to explain the risks to you, what could go wrong along your journey from point A to point B. Because nothing is as easy as it looks in the brochure. This is one of the reasons people are so excited about always-on availability groups, is that they read the brochure and it looks amazing. They just next their way through the wizard, as these guys did. It's only 5 developers. That's all they have. And as you guys have figured out by watching some of the stuff so far, always-on availability groups can be kind of challenging for a team of just 5 developers, even for a DBA, a full-time DBA focused on always-on availability groups. For example, if I can't get them to figure out why the cluster is just randomly locking up for no reason, always-on availability groups aren't really a good fit. As an outsider, when you come in and recommend something and you walk away, you don't want to get distracted by just saying, let me fix this for you and I'll leave and you'll be fine. Because if they didn't have the savviness to figure out why this thing isn't automatically failing over cleanly, then always-on availability groups present way more pitfalls for them down the road as they continue to use this stuff. The answers were right there. The reason that this thing is flapping over back and forth is I have 2 nodes in this availability group, and that's it. There's no witness, whether it's in the form of shared disk, which they don't own, or some kind of file share witness. File share witness being some reliable file server somewhere, which they probably do have. They didn't set up quorum correctly. So if I'm going to take this away from them, if I'm going to say, look, always-on availability groups, not the best fit for you, their goal was 0 to 1 second of data loss and around 1 minute for failover time. These are the 3 options that they have here. clustering with a SAN, synchronous always-on availability groups, or synchronous database mirroring. Availability groups has proven to be more complex than this team can manage. Could I probably just make a few tweaks to their infrastructure and walk away? Yes, but it would only be reliable today, not necessarily a month from now. Classic example, what happens when the file share fails? No one's going to get an email unless we also start talking about putting in some kind of third-party monitoring tool as well, which I don't know that I can entrust these guys to interpret the results out of. Failover clustered instance, while it sounds attractive and would meet their RPO and RTO goals, it doesn't meet their budget. They didn't say they had a SAN, and if they did, they probably would have said something about it. We totally could have asked them that as well. Normally, I'll find in small teams, if they do have a SAN, it's kind of a toaster type appliance. It's more of a NAS than it is a good SAN. And they're going to be disappointed if they go from fancy pants local solid state storage down to a toaster-like SAN. Database mirroring is interesting here because it doesn't require clustering. It doesn't even require a domain. It doesn't require a SAN. And everything here that they have is in one database. It's not spread across multiple databases. That's what database mirroring is perfect for. So what I would probably look at is, if you wanted to upgrade the operating system in SQL Server, you could, but you don't have to. SQL Server 2012 database mirroring is really the same thing as database mirroring in 2016. There haven't been that significant of changes going across there. So if I can keep this as easy and cheap as possible, is Win 2008 R2 the best operating system? No, but it works, and that hasn't presented problems for these guys, so I might want to keep it simple here in order to get this thing out the door. They are able to do this work themselves if I wanted to. Database mirroring, I could instruct them on how to go build it. They could even build it in flight. They would want to get rid of the availability group and maybe even get rid of the cluster. But we have two separate instances of SQL Server here. It's just a matter of setting up database mirroring there instead of setting up always-on availability groups. Are there risks? Sure. I do have to explain to them. They have to embrace and learn this technology. Someone's going to have to be the accidental DBA. Someone's going to have to stand near the database server and learn a little bit more about it. I'd really like to have them have some kind of pre-production environment, whether it's a couple of VMs or even just setting up 2 SQL Server instances on people's laptops and then failing those database servers over back and forth. Fred says, how many databases would cause you to move away from database mirroring? 2. This is what's tricky about database mirroring. If I'm going to do automatic failover, one database will fail over by itself. So if they even have 2 databases, that can present a problem when one database fails over and the other one stays behind. In a group of DBAs, we might say, well, I could script my way around that. Try to write that script first before you make that judgment call, because it is much trickier than it looks like, especially if I'm going to leave that script behind for a group of developers to maintain. Some of us said we would consider log shipping. Log shipping doesn't automatically fail over. These guys want 1-minute RPO and 1-minute RTO. Some folks also said failover clustering in their homework, but the bummer there is that we don't have shared storage. I would actually agree with you with failover clustering, except for one problem, going back to their RPO and RTO. So their goals here, notice this one around corruption. If I need automatic protection from database corruption, failover clusters only have one copy of the data and log file. It's on the SAN. So if there's any corruption, we're going to be restoring this thing back from disk. Restoring from disk restoring from backup, isn't hard at the 120 gig level. You're just not going to accomplish it in 1 minute. All right, so that's scenario 1. Now let's look at scenario 2, the scaled up SQL Server. This company built a big, huge monster. They built a big monster 32-core box, 768 gigs of RAM, and they're very happy in terms of performance. But management woke up one day and said, if this thing dies, we're boned. They're a large enough company. They have several developers. They have a couple of DBAs working on lots of database servers, not just this one. It was just that this SQL server never got the tender loving care of an architecture design to say exactly how much money do we want to spend and how do we want to fix this thing. So in the event of one server going bump in the night, they want no data loss and they want automatic failover within 1 minute. In the event of losing a data center, they don't want to lose more than an hour's worth of data or be down for more than a day. This is kind of luxurious. This gives us some time to do some manual processes here. For corruption repair, we don't want to lose more than an hour of data or be down for more than an hour. This is just a little bit tricky because in an hour, a human being can get sober, get to a keyboard, and do some work if it's well rehearsed and fast. You don't get a lot of second chances in the span of an hour, especially when we're talking about a database or series of databases at this size. At 3 terabytes and growing 10 to 20% per year, you're not restoring those. You can run a restore of 3 terabytes inside the span of an hour if it's extremely well rehearsed and performance tuned, and you have as much of a head start as you can possibly get. But I'm going to need some kind of corruption repair that either involves a separate set of databases ready to go somewhere or automatic page repair. Some of us suggested, for example, having storage replication going back and forth between 2 data centers. But remember, if SQL Server corrupts that data, if we have a bug inside SQL Server and it writes the disk or data to disk bogus on the first SAN, that corrupt data is just getting replicated to the other SAN. It is going to be challenging for us to pull that off that restore within an hour. Doable, just very challenging. One of my clients has a 15 terabyte large OLTP database server, and they're able to restore all 15 terabytes of data in that one database in less than an hour. To do it, they have all kinds of tricks around multiple 10 gig Ethernet cards, all solid state where their backups go, all solid state for the database. These guys are currently only doing full backups nightly, and they don't have any problems with performance. So the homework questions here were, first, what features do you want to use for high availability and disaster recovery? You're probably going to need a couple different ones in here. Pick at least one feature that's not suitable for high availability and disaster recovery and explain why. And then describe just at a high level, how do you want to implement this? So that 3 terabyte database, or sets of database, this is the first thing that makes me a little bit concerned. Doing a manual restore is going to be kind of tricky here. So I got 2 choices. Either I want automatic corruption repair, or I'm going to need to be able to restore as quickly as possible. We're going to talk about in our next modules how you go about using SAN snapshot backups to restore fairly quickly. But I can't only rely on this. I'm also going to need something else. Because if I take a snapshot of data that SQL Server corrupted, I'm boned. The second gotcha here is the database quantity. Whenever you see more than one database, like I talked about in scenario 1, the instant you have more than one database, you have to ask, when we fail over, do all of the databases have to be at the exact same point in time? Is it okay if one of the databases is a few transactions ahead or behind the other databases? When we talk about high availability, remember when the goals for this guy for his high availability was 0 data loss and automatic failover within 1 minute? Neither database mirroring nor always-on availability groups guarantee that you fail over the databases at the same point in time. This is so tricky because people see always-on availability groups and think that the databases fail over together, which is true, but do they fail over at the same point? That is not true. They're failing over together at the same time, but as we fail over, some databases may roll their transactions forward, while other databases roll their transactions back. Microsoft does a great job of explaining this. They go into very good detail inside this Books Online page, cross-database transactions for always-on availability groups and database mirroring, where they say cross-database transactions within the same instance are not supported for AGs. I cannot have a transaction that spans two databases on the same SQL server, even if the databases are in the same availability group. To go into more details, here's what Microsoft does support starting in SQL Server 2016. In 2016, if you meet all of these prerequisites, then you can do distributed transactions, meaning transactions across multiple databases. However, they have to be on different SQL servers. The databases, when I do cross-database transactions, one of the databases has to be on server A, the other database has to be on server B, which is mind-blowing for a lot of shops that use multiple databases per application. So this is tough. This rules out, because we have multiple databases, that rules out synchronous always-on availability groups. It also rules out synchronous database mirroring. Oh, hang on a second here. My dog wants to leave the room. Normally, she hangs out with me the whole time that I'm speaking until my wife wakes up, but she must have just heard my wife wake up. So that pretty well rules out for high availability based on their goals. I really only have one option. Clustering with a SAN is going to give me automatic failover if the databases all need to be at the same exact point in time when they fail over. However, DR is usually very different. In DR, if I say we're going to fail over all the databases, but some of them are going to be a few minutes behind or ahead of the other databases, at first, when I say that, businesses are usually like, oh, no, we need them all at the same time. But then we talk about log backups. So if you think about, you take log backups every minute, 5 minutes, whatever, they don't all happen at the same point in time. SQL Server backs up the databases, backs up one of the databases, backs up the next database, backs up the next database. So when you restore those log backups, they're not all at exactly the same transaction. They're all at slightly different transaction points. So I ask them, were you okay with that before? Usually businesses are like, well, yeah, I guess we were, because we just would be at slightly different points in time. I say, okay, great. So when I fail you over to DR, I have lots of options. I can use log shipping. Not all the databases will be at the same point in time. Async SAN replication or async VM replication. Fred asks, what are the recommended guidelines for how many databases should we put in an availability group? Unfortunately, there is no guideline for that. It all depends on your core count, how active the databases are, how many replicas you have, which version in a SQL server you're on. It's a big, huge monster topic. So what am I going to do for this? Sometimes I give people two options, and I say you can either do either one of these. I'm happy with either one. For one of them, I said, for high availability, I want a failover cluster with a SAN. Now, these guys are already comfortable with a SAN. They have nice, fast, speedy storage, so we're good there. And log backups every minute because they don't want to lose more than too much data in the event of things like oops deletes. For DR, one technique that I could use would be asynchronous SAN replication, say taking snapshots every 10 minutes, 15 minutes, or in this case of this business, they're willing to lose an hour. So I might take snapshots, say, for example, every 30 minutes. So say every 30 minutes off I go, take those snapshots and fail over. That doesn't get me corruption protection, though. In the event of a corruption issue, if SQL Server knowingly writes trash data to disk, option 1 means I have to have my restores tuned blazing fast, which, if I'm taking SAN snapshots, I can, but the SAN snapshots have to integrate with log backups, which is not a trivial concept. There are companies, EMC, NetApp is very good at this, that will pull that off. It takes a whole lot of work. What features do you recommend for option 2? So say that I give them a second option out there. I still like the failover cluster with the SAN for their high availability, but I could also be okay with always on availability groups because it will get me automatic page repair. Now, because it's async, they're not all going to be at the same point when I fail over. For example, if someone does a big, huge index rebuild, one of those databases may be way far behind in the others. Fred says, there's no Microsoft screenshot in your deck for what you were showing. I'm not sure which one you're talking about. Oh, can you give the link to this article? It's this. Just write down, or just it's in the deck, cross-database transactions and distributed transactions for always-on availability groups. Everything that I'm showing you in those 3 slides is all out of that post. It's a big, long article. It's like 10 pages long. It even gives you example scenarios of why transactions aren't supported across databases. It gives you an example of a transaction that would succeed in one database and roll back in the other. For a feature that doesn't work, I picked VM replication because a VM, while you can build a big 32-core VM, 768 gigs of RAM, they're happy with performance today on bare metal. I don't know that I would want to worry about introducing any performance issues. I'm not saying that this thing is too big to virtualize, but I only want to fix problems that they have. If they're not having a problem that would be fixed by virtualization replication, I probably wouldn't go there. My high-level project plan about how I'd sketch this thing out. First, I'd go build the brand new environment. I don't want to touch the existing SQL Server 2008 environment. It's working fine, but just leave it there. I'm going to go build the new one because I want to be able to test failovers back and forth, have everybody on the team screenshot and document it so they're comfortable with it. I have this expiration date philosophy. We'll talk about this today of how long do I want to have this hardware in place. Typically, companies want it in place for 3 years or more. If that's the case, I want to go with a newest version of SQL Server their app will support, just so that I know this thing's going to be protected as long as possible. Normally, I really like building, this is going to sound goofy, I like building SQL servers for 10 years, only because a lot of shops that I go into initially say, oh, we're going to upgrade this every 5 years, and then they don't. Then they go leave it in place longer. So I want to build something that's going to be rock solid and foundational that I don't have to touch again for a very long time. 2008 R2 will still be supported for, I want to say it's another 4 years right now. It's quite a long time, especially with Microsoft's new extended support options. So. Then to cut over, what I would do is set up log shipping, going from the existing environment over to the brand new one, doing the tail of the log failover that we talked about. So whenever we're ready to go live on go live night, we would take a backup of the log with no recovery in the primary environment. So then sealing that very good last transaction in there and then restoring it over on the new environment, I should be able to get the migration times down to, say, 5 minutes or less. Which is, usually companies get really excited about that at the 3 terabyte level. Javier says, I've still got a SQL Server 2000 running, believe it or not. Let me tell you a story about that. So, this story requires a prop. So I get a phone call. So the SQL Server 2000 is still running. Oh, I can top that by a long shot. Friend of mine emails me one day out of the blue. Hey, I got an urgent emergency. Have you got SQL Server 7? I said, no. Why on earth would I want SQL Server 7? And she said, well, these days I'm a database administrator at a government agency, and I just got a frantic phone call that the payroll system is down. She said, I didn't know we had SQL Server backing the payroll system. I'd never absolutely heard of it. So we go and find out, where is this payroll SQL Server? No one even knows where it is. And eventually they found out that it was in a closet that had been drywalled shut. During a renovation, someone went in and just said, we don't need this closet door anymore, took the door out, did drywall over it, sealed up the wall. And eventually this SQL Server, one day back there, poor neglected SQL Server 7 just stopped running. So they had to rip open the wall once they realized where this box was with the network cables going back in behind there. And then their problem started because the box wouldn't boot. They couldn't get Windows NT, whatever it was, NT4, to start back up again. So they built a brand new SQL Server from scratch, but they didn't have 7, and you can't download it online. So what we had to do was we had to go buy SQL Server 7 off of eBay. Somebody had an old box of it off of eBay just so that we could get the CD inside. We couldn't even find it on BitTorrent. And once we got it, then I could make an image of the CD and send it to her. And she was able to install it and get their payroll system back up and running. But you talk about a wild and crazy. That's still in existence today. Usually in our senior DBA classes, I'll ask, and people still have 6.5 running somewhere, running some mission critical thing that no one's allowed to touch. It's just horrifying what companies will leave out there once it works and everything is just fine. Speaking of which, yes, the real world is full of hard choices. So when we go through and sketch out these solutions, sometimes it's about changing what we're doing in terms of the business. Sometimes it's just writing a check for hardware and making the problem go away. And you start to understand how all these pieces play in together about the number of databases, the size of the databases, the number of the team members, the training of the team members. Sometimes we have to kind of dumb down the solution in order to make it easier for a small, hardcore group of people to manage who really don't want to focus on SQL Server to begin with.